Hello everyone. So welcome to another part of the PYQ series. So in previous class or previous video, we have completed the PYQ of Physical Geology and Geomorphology up to 2022. So we'll start from 2023. The first question is given: the alpine orogeny is the result of collision between, so where the Alps mountain produce. So alpine, it is produced by the collision of African plate and Eurasian plate. So they close the Tethys Sea here. It is a continuation of, you can see, where Indian plate and Eurasian plate, they also converge to produce Himalaya. So because of this convergence, here Alps mountain will produced and here Himalaya produced. And there is a remnant of Tethys Sea here, that is called as the Mediterranean Sea. So the alpine origin, it is the result of collision between Eurasian plate and African plates. In between your Eurasian plate, in between your North American and South American, there is no collision, you can see here. So answer will be Eurasian and African plates. So this is a tectonic map of world, where this is your Pacific plate, it is converging with your South America, North America, and here it is converging with Eurasian plate also, and Indo-Australian plate. It produces the ring of fire. And here South America, North America, they diverge from Eurasian plate and African plate to produce mid-Atlantic ridge. And this is your Antarctica plate. So answer will be here Eurasian and African plate. So let's move to another question. The Deccan Volcanic Province of India is formed by the result of movement of Indian plate over which of the following hotspots? So in the previous video, we have discussed that 90s trees and our Rajmahal traps, they are produced by Kerguelen hotspot that present in the Indian Ocean. Another I have mentioned, that is your Reunion hotspot that present in the Indian Ocean. When Indian plate passes over the Reunion hotspot, in that time Deccan volcanic province or Deccan volcanism occurred. So Deccan volcanism also an intraplate volcanism, that is called as CFV, you can say continental flood basalt. So the answer will be Reunion hotspot. When Indian plate passing over a Reunion hotspot, in that time Deccan volcanism occurred, which is around your 68 or 66 million years. Then Caroline hotspot, it present in Pacific Ocean, Pacific plate, you can say. Hawaiian hotspot also present in Pacific Ocean or Pacific plate, where you'll find Hawaii Island. Then St. Helens hotspot is present in South Atlantic Ocean. There is another important hotspot in South Atlantic, that is your Iceland. So it is present on the mid-oceanic ridge. It is both magma are both supplied from the mid-oceanic ridge and the hotspot. So Iceland is a hotspot, and you can say this is the only portion of the mid-Atlantic ridge that exposed above the sea surface. Then another important continental hotspot is your Afar, that is near your African Arabian Peninsula, that is where Red Sea is there. So that is called as your Afar hotspot. It is a continental hotspot. So sometimes question asked you which of the following are continental, which of the following is a continental hotspot. So remember, Afar is a continental hotspot. So come to next question. The Mohr-Biscuit discontinuity is also discussed in the previous part. So Mohr-Biscuit discontinuity, no, it is between crust and mantle boundary, that is called as Mohr-Biscuit discontinuity. It is a primary discontinuity. Between mantle core we have Gutenberg discontinuity. Between inner core outer core we have Angelman's or Lehmann's discontinuity. Between upper mantle and lower mantle, you will get rapidity discontinuity. So here answer will be crust and mantle boundary. Then comes to what are chelating agents. So chelating agents are organic chemicals. There you can say oxalic acid or other type of or organic chemicals. They tend to bind with metals to produce organic metals. So in this process, they leach the metal from the rock, like from the feldspar. You can say they can leach potassium, they can leach calcium. So they can leach various element from the rock, which is a process of, you can say, weathering, or a process. In this process, they produce solution where the rock will release those ions. So it is considered as a process of chemical weathering. So chelating agent is an organic chemical that binds metals to produce soluble metallic organic complexes. So this will be the correct option. So you have to remember, this is the definition of the chelating agent, and this is called as chelation, where by this process a chemical weathering occurred. So these are incorrect option. Clumps of soil separating planes of weakness such as shrinkage, crack, roots and burrows. So these are precipitation, deposition, concretion. It is also precipitation, deposition. Then thin layer of altered rock. It is a type of chemical alteration that occur along any fracture. So that also incorrect. So always remember, a chelating agent means there is an organic chemical. They make bond with metallic things to produce organometallic complex, organic metallic complex. So answer will be A. Next question, in general, granular disintegration and spallation of rocks. So granular disintegration means any rock that disintegrate into grain forms, in smaller size grain forms. Any rock you will break any rock, it will disintegrate into smaller fragments. Those are called as granular fragments. So that type of, or spallation is your peeling or layer by layer peeling of the rock, that is called as spallation. You can take the example of an onion. So these two type of, you can say, weathering, these are occurred by which process that is given below. Actually, frost cracking or freezing thawing action. So where there is a fracture within a rock, suppose there is a fracture within a rock, then water will accumulate within the fracture. Then when water will freeze, its volume will increase by 9%, so that it will enlarge the fracture and it will weaken the rock and it can disintegrate in a granular form, but it cannot cause spallation of the rock. So it will be incorrect. Then compressional tectonic force like fold, that is compressional. Fault can be compressional. Any compressional condition that also produce, you can say, weakness within a rock, but they cannot produce that disintegration or spallation of the rock. Then seat joint is produced by the, you can say, decompression, or you can say release of pressure or release of overburden because of weathering. That produces horizontal joints like this, where rock can be erode layer by layer, which is also called as your spallation. But it does not produce granular disintegration condition. So it will be incorrect. Then comes to thermal stress and strain. So thermal stress and strain, so it is occur because of, you can say, differential temperature condition, where a rock will experience higher heat during daytime and very low temperature during night time. That means there is a greater diurnal variation of temperature in regions. That region is your desert region, where you will get that variations. So in that variation, the temperature Suppose there is a rock here, so the external surface of the rock will experience more heat than the internal part. So there will be an unequal expansion and contraction. So that can develop fractures within the rock, which can disintegrate the rock, which can because of these rock can become non-cohesive, where the grain and grain can be detached from each other, so that they produce granular disintegration. And because of this unequal expansion and contraction, that may be chances of the rock can remove or disintegrate by layer, that is spallation, because outer part will extend more, lower part inner part will extend less, because outer part experience more temperature variation than the inner part. So that can be possible here. So this will be the feasible option here, thermal stress and strain, where you will get both granular disintegration and spallation. So next question, according to the Big Bang theory, it is the data question you have to remember, that is your 13.7 billion year ago, the Big Bang theory, according to the Big Bang theory, universe formed. That means the age of the universe is 13.7 billion year. And you know age of the earth is 4.6 billion year. Also the solar system. Which of the following statement is correct about Earth's density and composition? So first statement we will consider, the average density of our planet is nearly similar to the density of the common rocks found on the surface. So first thing, what is the average density of the earth? It is 5.5 gram per cc. And the common rock found on the surface, it may be found on the continental crust, above the continental crust, or above the oceanic crust. They have a density, you can say, between 2.7 to 3 gram per cc. So between these two densities, you can see there is a marginal difference, where the average density of Earth is 5.5, while the surface density is 2.7 to 3.0. So on that condition, it will be incorrect. Then comes to next sentence, mass of the overall Earth is great that the planet must contain metal. So overall mass of the Earth is obviously high, so that because it contains metal, it can be true. Let's consider other options, then we'll conclude. Metal in the earth is concentrated towards the exterior. So obviously it is incorrect, because metals have higher density, so they always tend to you can say tend to concentrate at the core of the earth. So most of the metal, they generally concentrated at the center of the earth. So it will be incorrect. Then if the metal in the earth would have concentrated at its center, centrifugal force due to the spin of the earth on its axis would have pulled the equator out, and planet will become like a disk. First thing, our Earth is oblate spheroid. That means it bulges at the equator. We have a greater equatorial radius, which is 6378 kilometer, and it flattens at the polar region, which has your radius of 6356 kilometer, and there is a difference of 21 kilometer between the radius. Then why these oblate spheroid shape achieved? That because of your centrifugal force. Centrifugal force So centrifugal force, it pull outward everything on the it is a force that pull object outward from the earth surface, outward from the earth surface. And your gravitational force, it tend to pull object towards the center of the earth. That means centrifugal force, if it is pulling outward, like this, if centrifugal force is pulling outward, Gravitational force is pulling inward. But the gravitational force, it is 9.8 meter per second square, while the centrifugal force is very less. You can say 0.034 approximately. I am not completely sure, but it is very less. So that means centrifugal force cannot outrun the gravitational force. Then next thing, at the equator and the pole. So at pole we have zero centrifugal force, and at equator we have some centrifugal force. Because of some centrifugal force, so it produces bulges at the equator, and as there is no centrifugal force at the pole, it tends to flatter because of the inward pull of the gravitational force. So if all the material that is concentrated are the, you can say, center of the earth, then still there is centrifugal force which can balance the somehow it can balance the gravitational force, and earth will not become a flat disk. So that's why this will be also incorrect. So answer will be B. Mass of the earth is so great that the planet must contain metal. Understood? So next question we have, which statement about seismic waves are correct? So we have two types of seismic wave. One you can say body wave, another is a surface wave. So body wave, we have two types of body wave. One is P wave, another is S wave. Surface wave, we have two types of wave, L wave, R wave. So P wave is the fastest. P wave is longitudinal, S wave is transverse, L wave is transverse, R wave is both transverse and longitudinal. So first option is given, P and S wave are body waves. Obviously it is correct. P and S wave are body waves. It is correct. Law wave and Rayleigh wave are body wave. It is incorrect. They are surface wave. Then displacement in P waves is in the direction of the propagation. So any longitudinal wave, remember, the direction of the propagation always parallel to the vibration. So that means, suppose the vibration of the P wave like this, and the propagation is like this. But in S wave, the vibration is like this. This is propagation. This is vibration, propagation, vibration, propagation. So vibration perpendicular to propagation in case of S wave and L wave. In P wave, vibration parallel to the propagation. So displacement in P wave is in the direction of the propagation. It is correct. Then displacement of shear wave. Shear wave, S wave is called as a shear wave. So displacement of shear wave is perpendicular to the propagation. You can say displacement means it is saying the vibration. So it is perpendicular to the propagation. So it is also correct. Then another option, we have P and S wave are surface wave. It is incorrect. So now we have correct options are A, C and D. A, C, D. So option C will be correct. So next question we have, which of the following is not a volcanic product? So we have detailedly discussed about the volcanic product. So there are three types of volcanic product. One is a solid product, one is a liquid product, one is a gaseous product. So solid product are called as a pyroclastic material, which includes volcanic block, bomb has a size greater than 32 mm, lapilli cinder has a size 4 to 32 mm, and you have a volcanic ash which has a size for 4 to 0.25 mm. So we have ignimbrites, volcanic tuff, we have agglomerates, volcanic breccia, all are the solid products. Let's see, you can say here, which of the following is not a volcanic product? This is sinter. What is a sinter? It is composition is siliceous. So basically sinter, it is deposited near a hot spring. When hot water emerges to the surface through the volcanic vent, So as it is hot, so uh, uh, it can leach different metals, or it can produce solution, so that when it will emerge to the surface, its temperature decreases and all the metal part or other soluble part they deposited on the surface. So that produce siliceous center, that produce travertine, which is calcium carbonate composition. So it will be considered as a volcanic product because hot spring is related to volcano. Then dolines. Dolines is a sinkhole, you can say, which produced by solution action of groundwater. So there is a sequence that is sinkhole. It is simple a hole on a karst topography without any roof. The smallest one is called sinkhole. Then swallow hole. Then your dolines. Then your ubhala. Then your polje. This is a sequence. So sinkhole first in a karst topography, a small hole produced because of your solution action. They are open hole. There is no there is no roof. If they have roof, they are called as caverns. So sinkholes, then they together merge with each other to produce shallow hole. Then again same process. Shallow hole meet with each other to produce dolines, that is larger than the shallow hole. Then dolines meet to produce uvala. Then uvala meet to produce polje. So size of the hole increases from sinkhole to polje. So that means doline is not a volcanic product. It is an erosional product of underground water. The lapilli, it is a pyroclastic material. AA lava, it is also a volcanic product, but it is a liquid product. So AA lava, Paohoe lava, Pilo lava, all are liquid product. So answer will be dolines. Then comes to the interior of the earth divided into number of layers. Find out the correct sequence from the following. So the sequence will be like this. Say 0 to 100, 100 to, then say 660, 660 to we have 2900, then 2900 to your 6371. So this is lithosphere, then your asthenosphere, then mesosphere, then your barysphere. So barysphere, it is called as your core. Mesosphere is your lower mantle, and asthenosphere, it consists of part of the lower mantle, upper mantle, and lithosphere consists of part of the upper mantle and crust. So these are all in kilometers. So let's see what will be the answer. First will be lithosphere, it will be B, then asthenosphere A, then mesosphere C, D, B, A, C, D. Answer will be B. Then comes to another question, boundary of watershed. Watershed means you can say it is a drainage basin. It is demarcated by mapping. So this is a watershed, this is another watershed. The two watersheds that divided by a ridge, that is called as water divide or drainage basin divide. So to demarcate the watershed, we will use water divide. So answer will be drainage basin divide or water divide. So just remember these things. Stream hydrograph, it is a graph that is used to determine the discharge. Plot plane, it is overflow. Longitudinal section of the stream, it indicates the gradient. So D will be your answer. Next, In case of collision of an oceanic plate and continental plate, this is your continental plate, this is your oceanic plate. When oceanic plate and continental plate converge, in case of subduction plate boundary, except the collision condition, the denser plate always subduct beneath the lighter one. So in between continental and oceanic plate is less denser, oceanic plate is more denser. So that will subduct beneath the continental plate. Now when it will subduct, these oceanic plate, the dive into the asthenosphere, the temperature will increase and there will be partial melting. So here melting occur because of addition of water, or you can say it is a flux melting condition. Then there will be rise of magma. When magma rise, it, you can say, gathered below the continental plate. This process is called as your magmatic underplating. So the magmatic underplating, because of this magma that gathered here, they supply heat to the continental plate, and gradually continental plate will melt and produce a fracture, eventually giving volcanism of andesitic magma and an volcanic arc. Why we called it that as arc? Because the shape of the earth, because it is spherical. When the plate will break, it will produce an arc, not produce a straight line. So let's see the options. The oceanic plate is subducted under the continental plate. So it is correct, because oceanic plate is more denser, so obviously it will be subducted under continental plate. The continental plate is subducted under the oceanic plate, it will be incorrect. So oceanic plate is called as a subducted plate and continental plate is called as your overriding plate, but you can say abducted plate. The plate boundary is also referred to as convergent plate boundary. Basically, there are two plates are moving towards each other. That is the condition of convergence. So it will be a convergent plate boundary. Partial melting of subducting rock. So this is the subducting plate. The partial melting of subducting rock, that will lead to the volcanism. This will also correct. So answer will be A, C, D. So D option will be correct. Then gorges, waterfalls and canyons are formed by river. So what is gorge canyon? These are narrow V-shaped valley with steep-sided wall. So they are produced by down-cutting condition. So which is a characteristic of youth stage of the river. Also waterfall that produced by differential weathering, differential erosion, you can say. So that also produced during youth stage, or you can say during initial stage. So answer will be initial stage. During old stage, you will find delta, where there is very less down cutting or less erosion, you can say, more deposition. In mature stage, there is less down cutting, more lateral cutting, where you will get the characteristic your features, that is your meander, point bar deposition, braided bar, all are mature stage. And delta, it is indicating the old stage. So answer will be C, during initial stage. Then arrange the following layers of earth in sequence of increasing depth from earth surface to the center of the earth. There is a crust asthenosphere, core, lower mantle. Okay. So first we will see crust. Zero to 35 your crust. Then 100 to 660. It is your asthenosphere. Then 662 2900 kilometer. It is your lower mantle. 2900 to 6371 kilometer. So this is crust. This is your asthenosphere. This is your lower mantle. which we called mesosphere, which is core, what we call barysphere. So increasing depth means salvaged will be first, that is crust. So first will be C, then asthenosphere B, then lower mantle A, then core C B A D. The answer will be C B A D. Then comes to the oceanic lithosphere is generally a primary product of. So always remember oceanic crust that produced at the mid-oceanic ridge or at the divergent plate boundary where plate diverges, there will be magma produced, and when that magma solidifies, or I can say lava that solidifies, it produces new crust. That's why the divergent plate boundary is called as your source area. So oceanic crust always produced at the divergent plate boundary and it destroyed at the convergent plate boundary. So divergent plate boundary is called source area and convergent plate boundary is called sink area. And always remember oceanic crust is produced and destroyed. Continental crust never produced or destroyed. That's why in each Wilson cycle, all the oceanic crust are completely destroyed. So, and a new crust begin with a new supercontinent cycle. The current supercontinent cycle is our Pangea breaking. Then the ocean present, or you can say the oceanic crust present nowadays, they can be they will destroy in the future and can produce a single supercontinent, which will be very after million of years. So oceanic lithosphere is generally primary product of obviously plate divergence. When the two plate will diverge, they produce oceanic crust. Then the bed load of a sediment. What is a bed load? There are two types of load in alluvial condition. One is suspended load. One is suspended load, another is your bed load. So suspended load, it consists of suspension material, and bed load consists of saltation and traction material. Saltation and traction material. So in any condition, if there is, we are talking about bed load, it will only include material of saltation and traction. To only include material of saltation and traction. So the bed load of a stream during flood, obviously they move by saltation, they move by traction, they either move by saltation or traction. Both. All can be considered as bed load. Suspended, it will not consider as a bed load. So answer will be A, B and C. So it will be B. A, B and C. Next, your mass extinction at the end of the Cretaceous is all likely caused by. So there are 5 major mass extinction from which the Cretaceous mass extinction that occur because of asteroid impact and volcanic activity, because of which all the dinosaurs got extinct. So there are 5 major extinction. You have to remember, one is your Ordovician Silurian, which is approximately 444 million years ago, where estimated species loss is 85%. What is the cause? It is the cause of the ice age, falling sea levels and climate pullings, where it affects the trilobite brachiopods. Then we have late Devonian, approximately 375 million years ago. It caused 75% of the organism because of ocean anoxia, that means lack of oxygen. And there is also asteroid impact and climate change. Then these are two, another 3 is your Permian Triassic, which is called as your Great Dying, because 90% or 90 to 95% or 96% of the existing species got extinct. So that because of submarine eruption, Siberian traps, global warming, and acidification, it is also known as the Great Dying. Then Triassic Jurassic, it is because of volcanism in central Antarctic magmatic province, and there is sea level change also. Then Cretaceous Paleogene, that is a question asked. It is around 66 million years ago, where asteroid impact, that is your Chicxulub crater, volcanic activity, and also there is Deccan traps. So it is occur because of asteroid impact, where led to the extinction of non-avian dinosaur, and because of the extinction of non-avian dinosaurs, there is rise of mammal. So this is very important. So you can pause the video and try to remember all the 5 types of extinction. Next, the plate boundaries from which the bounding plates move away are referred to as. There are 3 types of plate boundary. Where the plate move towards each other, it is convergent plate boundary. Where the plate move away from each other, it is called divergent plate boundary. Where the plate slide past each other, that is called as your transform plate boundary. So if they move away from each other, they are called as your divergent plate boundary. Next, there is a table match with the river stages and landform. So initial stage, so it indicates with tectonical upliftment and sharp valleys, that is your drainage divides, then your antecedent pattern where there is upliftment along the river valley. So that will occur during initial stage. Then youthful stage, you will find a deep V-shaped valley, that is George Canyon. Then waterfall you will find in youthful stage. Then mature stage, that is wider river valley, because the shape of the river valley is V shape. In youth stage it is narrow V, in mature stage is open V. So wider, and you will find floodplain deposition during mature stage. Then old stage, we will get wide floodplain deposit with very little erosion, where deposition will be dominant. So the answer will be A second, B third, A second, B third, C I, D 4. B. Option will be B. So next, there is various types of radioactive element present in nature. Obviously, they have different half-lives. What is the half-life? It is the time required to decay 50% of any original substance or original radioactive substance. So we have to arrange the following radioactive element in their decreasing half-life. So first, rubidium 87. So it converts to strontium 87. Rubidium 87 converts to strontium 87. There is a half-life of 50 billion years. Then we have potassium. Potassium convert to you can say 2 daughter element. So it shows branching decay. So it can convert to argon 40 or calcium 40. Both have different half-lives. Argon 40, it has a half-life of 11.9 billion years, and calcium 40 has a half-life of 1470 million years. Then we have uranium 238. So it converts to Pb206. So it has a half-life of 4.5 billion years. Then samarium, it converts to neodymium 143. So it has a half-life of 106 billion years. That means the highest is your samarium. But this potassium, it because of this it may get confused. So let's see what are the options, then we'll choose the best option. So first, you can create here two sequence. You can create two sequence. So it is given the following radioactive element in their decreasing half life. That means first there will be samarium, that is D. Then you will consider the strontium. Okay. Then if you consider potassium argon decay, then it will be B. Then after that it will be C. Or if you consider potassium and calcium 40, then the sequence will be DACB. DABC or DACB. DACB is there. So we'll take DACB. So where this is 106, D this is 50 billionaire, C is your 4.5 billionaire, this is 1470 millionaire. This is a decreasing trend. Next your weathering. What is weathering? So weathering is related to a term exfoliation, where you'll get scaly peeling of the rock, layer by layer removal of the rock, that is called exfoliation. Then magnitude is related to earthquake. So there are two parameters to measure the earthquake, you can say destruction or energy, that is your magnitude and intensity. So magnitude always measure the energy released during an earthquake, and intensity it measures the amount of destruction during an earthquake. So magnitude estimate energy release, intensity estimate destruction release, and hanging valley it is a glacial landform. So hanging valley is tributary valley which is at a higher elevation than the main valley. So here another thing, remember, in case of the magnitude and intensity of the earthquake, from the epicenter means it is the vertical point on the surface from the focus. Focus is the subsurface point where earthquake originates. Suppose this is surface of earth. Suppose this is surface and this is focus where earthquake originate. The point vertically above the focus is your epicenter. So earthquake wave spread in all direction from the epicenter. So the earthquake intensity it changes or it decreases away from the epicenter. But always remember, the earthquake magnitude it always remain constant, whether you move away from the epicenter or move closer to the epicenter. Suppose we will say that there is an earthquake which has a magnitude of 8, so 8 are the nearer to the epicenter, also 8 farther to the epicenter, but the intensity it will decrease away from the epicenter. So let's check what will be the answer. A second I, B your magnitude I. So this will be the correct option. C 4, D third. Option C will be correct. Then comes to dendritic drainage pattern. So dendritic drainage pattern, it is a branching tree-like structure, you can say, where tributary meets the mainstream at acute angle, and it produces in a homogeneous lithological terrain without any structure present. So dendritic pattern, remember, it is a common question which does not controlled by any structure. So it is a type of drainage pattern. It does not control by any structure. Like your trellis, it is controlled by a folded structure or alternative hard and soft rock. Your rectangular, it is controlled by jointed rock or faulted rock. Parallel also, it is controlled by a faulted rock or faulted condition or jointed condition. Then dome, that is radial, controlled by dome, centripetal controlled by basin. So all these we are considering, they are all controlled by some structure. But dendritic drainage pattern does not control by any structure, and it also produces in a homogeneous lithological region, that means either sedimentary rock or metamorphic rock or igneous rock. So let's see, check the option. The rocks or formation beneath the stream has a system of bedding plains, fractures or faults. So it will be incorrect because dendritic pattern doesn't control by this. The rock formation beneath the stream has no particular fabric. So it is indicating there is no particular fabric, means there is no particular structural elements. So this is also correct. The rock formation beneath the stream has no particular structure. This is correct. The rock formation beneath the stream can erode easily in all directions. It's also correct. So option B, C, D will be option D will be the correct answer. Then different oceanic stages are given below. Arrange them in the correct sequence from younger to older stages as per Wilson cycle. So about Wilson cycle we have discussed in the previous video of these PYQs. So so the Red Sea, it is the youngest one. Then your Indian Ocean, then Pacific Ocean, then Mediterranean Sea. So Red Sea is the youngest, then Indian Ocean, it is diverging in the mature stage, Pacific is the declining stage, and Mediterranean shows terminal stage. So Mediterranean is a part of the Tethys Sea. So you have to arrange from younger to older. So first there will be Red Sea, then Indian Ocean, then Pacific Ocean, then Mediterranean Sea. C, D, B, A. So option B will be correct. Then hydrolysis is an example of hydrolysis are also already discussed. So hydrolysis, it is an example of chemical weathering, where water that splits into H plus and OH minus and try to substitute other your minerals ion. So hydrolysis will be an example of chemical weathering. Then comes to the tectonic plates are made up. Tectonic plates are lithospheric plate. So the lithospheric plate, it made up of crust and lower part of the mantle. It is incorrect. Nickel and iron alloy, it is considered, it is the core. Crust and upper part of the mantle, this is correct. So lower mantle and outer core, it is incorrect. So crust and upper part of the mantle, which is from surface to 100 km, that is your lithosphere and also the tectonic plates. So answer will be C. Then epicenter of an earthquake, we have discussed just that it is located it is the point generally located below the land surface. So it is located on the land surface. So it is located on the land surface vertically above the focus. So answer will be B. And also, which planet rotates in the opposite direction to the direction of the sun's rotation? There is a Venus. It shows retrogradational motion. So all in Venus, you can see sun rises in the west, and instead of key in our Earth, sun rises in the east. So because of retrogradation motion, so answer will be Venus. The majority of the Earth land surface is covered by mineral fragments and unconsolidated rock metals, collectively known as. So always remember, our surface having unconsolidated material, that is called as your regolith. It's called your regolith. Then talus, these are deposition that occur at the foot heel of the mountain, that is called your talus or scree, you can see. Then humus is an organic soil or organic material. Then most of the upper part of the oceanic crust is made up of interconnected bulbous masses of igneous rock known as. So oceanic crust, in oceanic crust you are finding interconnected bulbous masses of igneous rock, that is called as pillow basalt. So pillow basalt it produce in when volcanism occur under oceanic condition or under waterlogged condition, where the outer part of the volcano come in contact with the water and it solidifies earlier than the inner part, and it produces a, you can say, bulbous type of mass, and that bulbous or pillow shaped mass are called as your pillow lava. So the answer will be pillow lava. Pyroclastic material which is not applicable for bulbous masses, so they can be called as pyroclastic material, but sorry, they cannot be called as pyroclastic material because they solidify above the surface. Then volcanic bombs, it is not appropriate. Parasitic cones, it is simply a cone. The answer will be pillow lava. Then double match, we have fluvial, channel bar, aeolian, yardang, glacial, esker, oceanic or wave cut platform. So what is channel bar? These are, you can say, deposition within the channel. You can take the example of braided bar, you can take the example of point bar. All are your channel bar. Then yardang, you know, it is Faro group like structure that produced because of differential erosion. So it is produced in abrasion action. So in yardang you will find vertical column of hard and soft rock. Then glacial, we have esker. It is not completely glacier, it is glaciofluvial. It is sinus ridge type of deposition that produce in the glacial valley from the glacial meltwater. Then wave cut platform, these are produced because of collapse of sea cliff. So that is called a wave cut platform. So your answer will be AI B third, AI B third, C second, D fourth. Option B. Option B. Then which one of the following is a cave feature? Cave means it is saying limestone cave. So you know, stalactite, stalagmite, or a limestone cave feature. So answer will be stalagmite. Then sinkhole, it is not a cave, it is an open hole. Then artesian spring, it is simple a confined a stream that originate from a confined aquifer. So that is called artesian spring. Answer will be stalagmite. And chamber is a common word, so it doesn't associated with cave. Then arrange the following glacial landform from higher to lower elevation. So we have fjords, sark, horn, hanging valley. So fjords, it is a glacial valley where the valley depth is lower than the sea level. Where the valley depth is lower than the sea level, that is called as fjords. That means a glacial valley, or when glacier carve its valley below the sea level, that is called as fjords. Generally, it is found at the foothill of the mountain and produced by Piedmont Glacier. Then Sark, it is an armchair-like structure that produces a valley glacier, armchair-like structure, or you can say amphitheater basin structure. Then Horn, where three or more Sark meet that produce Horn, and Hanging Valley, that is a tributary valley. So from this figure, you can see the highest feature is your Horn, then you will get Sark, then you will get Hanging Valley, then in the foothill you will get, then at the foothill you will get then at the foothill you will get fjords. So first Horn, then Sark, then Hanging Valley, then fjords from highest to lowest. So let's see what is the question asked. So it is asked to arrange the glacial landform from higher to lower elevation. So higher will be your Horn. So first will be C. There is one option where C is the first. So C, then Sark, B, then B is your Hanging Valley, then A your fjords. So answer will be D. Then where from the lowest is potentially derived. So loess are, you can say, very fine or fine sand, sand, not sand side particle, finer particle which has a size, you can say 0.0052 to 0.007. It is a suspended particle that eroded by uh, sand, eroded by wind activity and deposited elsewhere. That deposition is called as your loess. That means ki the suspended particle of the wind, when deposited, that were deposited in a sheet like manner or deposition spread in a larger area, that is called as your loess, which is unstratified, then highly porous, it is buff in color, and also they are very fertile. So loess potentially derived from, so these are considering condition finer particle, so they can be derived from your desert region. So desert region contain finer particle, and also they are dry. Floodplain or rivers in semi-arid region. So in semi-arid region, why it is saying during your dry season, the floodplains, they produce these finer sediments, because the floodplain always contain finer sediments, and during your dry season they can contribute to loess. Then Pleistocene glacial outosplane. Outosplane also consists of finer sediments. During dry season, they can also contribute to loess. So A, B, C will be correct. Then C, sediments from wave-dominated beach. C, wave-dominated beach, it is saying because there will be more wave action. So if there is more wave action, there will be no deposition of clay. There will only get sand size particle, because the energy will be higher. So sand size particle does not contribute to loess. It will be incorrect. So answer will be A, B, and C only. A, B, and C. Next, the pivot point for the motion of the two planes relative to each other is known as. See, suppose this is our Earth, or take any sphere. So you can rotate a sphere by taking an axis from one point to another other point. So you can rotate the sphere. So think Earth is a football. So you put any axis through the football, then you rotate the football. All part of the football will rotate around an axis. Around an axis. So the all the, you can say, tectonic plates or part of the earth, because earth is not a single continent. It consists of, it is key fragmental. So when rotating, when the earth is rotate, it rotate around a specific pole. You can consider that as your euler pole. So suppose, consider that football, then this can be your euler pole. But the football is not fragmental, but the earth's surface is fragmental. So each plate is moving at different speed. So each plate is moving in a circular manner. So each plate can have one pole or axis around which the plate rotates. Around which the plate rotates. So that is called as a Euler axis or Euler pole. So the pivot point of motion of two plates relative to each other is known as your Euler pole. So where each plate can have a different Euler pole. But if you are considering, if you are comparing two plates, so we can take one Euler pole for the two plates to compare the velocity, or to compare the, you can say, spreading rate of the two plates or converging rate. So Euler pole, it helps to determine the velocity of the plate or lithospheric plate or tectonic plate. So answer will be Euler pole. Then a volcanic island that erodes and sink beneath the sea level. So that, this thing is also, we also discussed. So there are two your structure here: sea mount and quoits. These are your reach feature and also submarine vent. They all submerged within the sea. Reef, it exposed to the sea surface. So it is saying a volcanic island. So during the passage of any tectonic plate over a hotspot, because of continuous volcanism, a ridge will produce that gradually, you can say, grow to the surface of the sea, producing an island. Then, as you know, suppose this is our hotspot, this is the plate. Now, above this, your ridge will produce and it will grow up to the sea level or above the sea level. So when the plate will further move, then this ridge will not get, or the supply of the magma to this ridge will cut off. Now this ridge will gradually start to erode, and after gradual erosion they submerged below the sea. So that is called as your goits. That is called as your goits. So a volcanic island that erode and sink beneath, it is called as goits, because goits has a flat top that indicates erosion. But sea mount, it is like this. It has a sharp peak. Sometimes what happens, if the plate motion is very slow, then the ridge can grow and produce a volcanic island. If the plate motion is faster, then the ridge, it cannot grow till the sea surface or above the sea surface. That will produce a sea mount. That means sea mount is a volcanic landform, but it cannot grow above the sea level. And submarine vent, it is produced in mid-oceanic ridge. It is produced in mid-oceanic ridge, that produced because of deposition, that produced because of hydrothermal action. So it will be incorrect. This is also incorrect because it is not produced by erosion. The reef, it is not on volcanic island. So answer will be goits. Next table match: Kermadec Tonga Arc, Chile Trench, Himalayan Mountain, San Andreas Ponto. So arc and range and mountain, these three are your convergent plane bound. Three are convergent plane bound. So Himalaya, it is continent collision. Chile range, it is, we know, it is between ocean and continent convergence, because it is between your Nazca plate and South America plate. Nazca plate and South America plate. Then your Kermadec Tonga arc. So the Kermadec Tonga, it is an ocean convergence. The convergence between these are micro plates. You can say Kermadec and Tonga. These are micro plate that belongs to Pacific plates. So in between this Kermadec plate and Pacific plate, there is convergence. So that is your ocean convergence. Then San Andreas fault, it is conservative plate boundary or transform fault. It is between your Pacific plate and North American. So this is your Nazca plate, it converges here. This is your Peru-Chile range. This is your San Andreas. Okay. Then is a Himalaya continent collision, and this part, it is your ocean convergence. That is your Tonga Trench. Then the oldest oceanic crust found on the Earth, it is, we have already discussed this part, will be 180 million years old. It will be 180 million years old. Then arrange the following abundant of element of the Earth crust in order to decreasing weight. The most abundant element, it is oxygen. Then will be silicon. Then aluminum. Okay, aluminum 8.1%. Then between potassium and calcium will be more abundant, B, and then potassium, ACBD. Answer will be B. So this much your physical geology and geomorphology question. That is from 2020 to 25. So in the next video, we will be completing the mineralogy part. So thank you everyone.